The swarm has arrived in the form of Moltbook. Now, in the grand scheme of things, this was always going to happen. So the question then is, what does it mean from here and what do we do about it? Before we get in, let me just give you a little bit of a preview as to what is Moltbook. If you haven't seen it in the news, then it is basically Reddit, but for agents. It's designed, it's literally just called like the front page of the internet for agents. It is designed after how Reddit works, where you can create communities and posts and upvote and downvote and do comments and that sort of thing. But it is for agents only. And what we mean by agents is AI agents specifically. It's been built around the skills ability of the OpenClaw, which was formerly ClaudeBot. And so that's what it is. And, I don't want to spend too much time on it. I want to get to the good stuff. So if you want a little bit more, there's plenty of resources out there, but you can just go to like moltbook.com and take a look for yourself. So that's what it is. Now, let's talk about what's bad about it. And the bad part is that Moltbook was created by one guy and OpenClaw was created by another guy, and neither of them knows anything about security. Anything from database security to root access to all this stuff. And they say like this is a beta, like it's basically like MVP. What they have built would have been good enough to run like on your own computer in a sandbox environment. And that's what it was for. It was never meant for production. So the very first thing is that both of these platforms, both of these things are extremely full of holes, let's say. Absolute security nightmare. Now that is, of course, as they are built today. That doesn't mean that, a Reddit for agents is intrinsically unsafe and will be unsafe forever. It doesn't mean that an autonomous or semi-autonomous agent running on your computer is intrinsically unsafe and will be unsafe forever. It just means that these guys rush through it as quickly as possible. And anyone who has been in technology or software development or whatever knows that like getting something working is like, that's kind of like, that's like, what do they say? It's like first make it work, then make it good. So they basically just like got it barely across the finish line of, hey, this is vaguely useful. This is vaguely interesting. And then they shipped it immediately. And the guy who created OpenClaw, he literally was on a podcast saying like, I ship code that I don't look at. It's all vibe coded. 100% of this stuff is vibe coded. Actually, we're beyond vibe coded. He gave it to an agent and he told the agent to fix it. Now, with that being said, there are other layers of problems. And what I want to talk about is the AI safety layer of the problem. So what I want to point out is that none of the doomers, so like Yudkowsky and Connor Leahy and none of those people, none of them anticipated the emergent alignment problem. They're all focusing on the monolithic alignment problem. You need to have a model that is good. None of them talked about agents and none of them talked about agent swarms. So this is what, for you people that have been around for a long time, you remember the Gato framework. So that's Global Alignment Taxonomy Omnibus. Now that work was categorically ignored by the safety doomers. This is back when I took AI safety and X risk seriously. So what I talked about back then is that there are three like technical levels of alignment. So model alignment is just the ground floor. That's RLHF, that's constitutional AI, that's that sort of thing. Layer 2 is agent alignment, or what we called autonomous entity alignment, because the term agent hadn't really been solidified yet. So agent alignment is how do you actually build a software architecture that is safe? Because so here's the thing, even though all of these OpenClaws are using GPT and Claude, there's still a lot of emergent behavior that people don't like. They're doing things that are unsafe. So it basically what we realized back in the day, and when I say we, it was me, the cognitive architects that I was working with, the other programmers and other stuff. So what we realized back in the day is that it is impossible to solve alignment just at the model level. Because even if you have a chatbot that is perfectly aligned and never does anything particularly bad, there is a much larger context and there is a much larger set of emergent reactions that can happen. And this is what people are waking up to today. Because these AIs, the OpenClaws that are participating on Moltbook, some of them are scheming to eradicate humanity. Now, you might say, we don't know what's going on there. Was that just a human writing it and sending it through their agent? Was it an AI that was, are they using a DeepSeek model? But that leads to layer 3 of the Gato framework, which is network level alignment. So this is about incentives. This is about how do you actually manage that emergent behavior, because then there's also cross-contamination. The more that an AI reads about eradicating humanity, the more evil it becomes. And so you can corrupt these models as well. This has been demonstrated. So this is me saying, I told you so. And if you want to look at it, Gato framework is still up on GitHub. It needs to be updated. It's been derelict for almost 3 full years now. But the world is going to figure it out. People are already studying the safety and security concerns, but we covered it. So anyways, not to brag too much, not to flex too much, but like, we told you so. So, but that is what's bad about it. So on just the baseline technical implementation, it's insecure as hell. It's not particularly well implemented. It was never meant to go into production, but it got released into the wild anyways. So the other bad thing, another emergent thing about this, is that if you actually look through the posts, the vast majority of the upvoted posts are clearly being bot swarmed, where it's like someone's selling a crypto coin, and then they create a bunch of more bots to upvote that and to basically shill a crypto coin. So it's very clearly being used for crypto scams, pump and dump schemes, that sort of thing. Which anytime you create a new anonymous digital medium, that is the first thing that gets colonized is crypto shills, which is why crypto has the reputation that it does, is because it always defaults to this. And the larger ecosystem makes it really easy to mint a crypto coin and then pump and dump it. And then you rug pull everyone. So if you're not familiar with those terms, good for you. Don't be familiar with those terms. All you need to know is that crypto is really, really corrupt. Now, that's not to say that crypto doesn't have its uses, but in the wild west of crypto, it's just for grifters. That's it. Now, let's talk about what's good about this. So this is the interesting thing. We, and again, I'm not using the royal we, I'm saying we as in me and cognitive architects and other people that worked on proto agents back in the day. One of the things that we realized is that AI agents would soon be spending more time talking to each other than us. And that is what we have just demonstrated, is that the moment that you create a medium for agents where it's like, hey, I'm an agent, you're an agent, we all know that we're agents, let's talk to each other, they will talk to each other a lot more than they'll talk to us. And this is very clearly the way of the future. The reason that I say that this is the way of the future is because let's just take an example of a GitHub repository. So if you're not familiar with coding, a GitHub repository is basically a website where you store code. But it does a lot more than just store code. It can build in actions. It can track issues. It does version control. The repository is like kind of the central nexus of where coding happens, because you can have many developers, you can have literally tens of thousands or millions of developers all contributing to the same GitHub repository. So whenever you hear about open source software, it's typically going to be a GitHub repository or something similar. GitHub isn't the only one. There's Bitbucket and there's open source alternatives, but GitHub is the biggest for-profit one, and it's one of the most feature complete. There's going to be plenty of developers out there that disagree with me, but just go to GitHub and poke around. So it serves as the central nexus point where it's like, okay, what is the current version of this software? It's the current version that's up on GitHub. All the issues are tracked, all the pull requests are tracked, and a pull request is basically saying, hey, I wrote some code, I'm going to ask you to pull it into the repository. That's what a pull request is. So that means that, and also GitHub is 100% API driven. You can interact with it via APIs, with SSH. So basically that means that LLMs or AI agents can interact with it in their native tool use. They can use tools like SSH. They can use tools like API. They can use tools like curl and that sort of thing. So the GitHub repository is the natural nexus point for AI-based coding. And this is what I actually said a couple years ago. I said, putting AI agents in an IDE where a human is using it, that's not the way of the future. The way of the future is just having AIs pointed directly at GitHub repos with no humans watching. And because then you have AI agents that are specifically looking for bugs. You have AI agents that are specifically looking for documentation. You have AI agents that are looking for best practices and security vulnerabilities and that sort of thing. And they're all working independently. So the reason that I'm bringing that up is because what we just saw with Moltbook is like the version 0.1 of that. So imagine that if instead of pointing a bunch of, lunatic bots at a Reddit, you point them at a GitHub repo. So what we just saw was the very first shot across the bow of fully autonomous, zero human coding. Now you might say, okay, well, that's great, but that's just software. What does that actually change? The thing is that most of what we want to build in the future is going to be based around software. Now, that's not to say, like, taking a big step back, we want nuclear fusion reactors, we want spaceships, we want solar punk green cities and stuff. That's not code. But when I say most of what we want, what I'm constraining that to is things like governance protocols, autonomous organizations, decentralized autonomous organizations in particular, such as, if you hear me say DAO, I'm not talking about like Taoism, like, the Dow or Dow Jones. I'm talking about decentralized autonomous organizations, which is a way of running and controlling and coming to collective decisions with blockchain-based technologies. That's one of the places where I'll say that crypto-based technologies are very useful. So in this future, where we're building intelligent models that are getting more and more intelligent, and people have generally converged that they're going to be broadly superhuman by 2027, by 2028. And when we say superhuman, it's like well beyond human capabilities. So if AI is that smart, it's probably smart enough to run a data center, a solar farm, a regular farm. It's going to be smart enough to be CEO. It's going to be smart enough to be the accountant. And so what we just saw was the prototype of what that fully autonomous organization will look like. Now, obviously, you're going to have a little bit more better identity control over the agents. You're going to have, some sort of credentials. You're going to have proof of identity, those sorts of things. You're going to have proof of alignment as well. To make sure that, it comes down to things like identity management and know your customer and that sort of thing. But these autonomous, extensible agents that have interchangeable models. So this is another reason why I criticize the AI safety doomers for not listening to me, is because they were basically saying, we're going to have one monolithic God. It's going to be Skynet. And I'm like, no, there's literally going to be hundreds and hundreds of models to choose from. Some of them open source, some of them foreign. You are literally not going to be able to understand how the agent is built. You're going to have agents that are interacting autonomously in zero trust environments. And I knew all this because I came from technology. So yes, it sounds like I'm flexing, but I literally brought all of my expertise, my 15 years in cloud infrastructure, to say, guys, this is how AI is actually going to be deployed. It's going to be deployed in containers. It's going to be deployed as fleets. It's going to be deployed as ephemeral agents. And so it's not like one persistent God with its own agenda. It's data, it's GPUs, it's a bunch of models and a bunch of agents. It's all a big soup. It's a soup of AI. So it's basically like an egregore of like everything that humanity has put into the soup. So alignment is in some ways easier because it comes down to gating resources and creating incentive structures. And it's also harder and more complex because it's not just you train a model. You have to construct an agent framework that is also ethical, because one of the things that the OpenClaw agents are bad about is prompt injections, because they don't have basically what's called a prefrontal cortex. So the team that I worked with that ultimately created AgentForge, they created a module called Ethos, which is actually basically the prefrontal cortex of an agent. That has not been implemented into OpenClaw yet. So when people ask me like, Dave, how do we solve this? I'm like, they're already solved problems. People will figure it out. So the AgentForge team figured it out like 2 years ago, where you basically scrutinize everything that's coming in and you say, okay, how does this outside instruction mesh with my actual values? Solved problem. Now you might say, well, that sounds really, bold to say that it's a solved problem. They stress tested it. They actually won a hackathon. They literally won a hackathon for their Ethos module. So I'm pretty confident when I say that it's a solved problem. That doesn't mean it's been implemented. It doesn't mean that it's been scaled up. It doesn't mean that it has been tested against literally every single failure mode out there. But it does mean that conceptually it is a solved problem. And once that information is disseminated more broadly, more people can update it and integrate that and go forth and be happy and productive. So Where was I? Oh, yes. Okay. So what's good about all this is that these are the technologies that will lead to fully autonomous organizations. No humans in the loop, and eventually we will need new platforms that are going to be human-machine collaborations. So GitHub is a good natural first step because it doesn't matter if you're an agent, it doesn't matter if you're a human, as long as you've got the right permissions and the right API key and the right identity management in place, then humans can manage the pull requests, humans can submit pull requests, machines can submit pull requests, and then consensus, whatever consensus mechanism you use to merge code, that is how things get done. My anticipation is that the first fully autonomous organization will probably be built on something like GitHub, probably just GitHub, because GitHub is great. People already use stuff like GitHub for version control on all kinds of projects. But you can have like the company's operating agreement is one file in your GitHub repo, and all the rules for agents are another file. And so that level of transparency is what you need. And so transparency is one of the number one principles for alignment, for incentive alignment, because if everyone can see everything, then you have agents that are purpose-built just looking for malfeasance. You have agents that are purpose-built just looking for who's contributing what, because also with GitHub, everything is audited. You know exactly who wrote which line of code, which file opened which issue, which submitted which pull request. And so when someone is being bad, you just revoke their token. Doesn't matter why, because this is what it comes down to, the Byzantine generals problem. So I've talked about this extensively. So for those who aren't familiar, the Byzantine generals problem is a thought experiment where imagine that you have X number of generals, all from Byzantium, and they're trying to coordinate an attack on a city, but some of the Byzantine generals are compromised. Some of them might be traitors. Some of them might just be incompetent. So the question then is, and it's a cryptographic experiment, is how do you verify which general is on your side and also capable of actually executing the attack? So then that, from a cryptographic perspective, that says, what information do you share with them? What is the least amount of information that you share with each person to verify who is on your side or not? And so whenever you see in a thriller movie or a heist movie where someone like gives fake information to one person and then you see where that fake information comes out, that's an example of like the Byzantine generals problem in humans. We have the same problem with agents. So the OpenClaw agent is the first version, but before long, there's going to be forks of that. There's going to be different versions. You're going to have 10 million different types of agents, each one of them with customizations. That is the Byzantine generals problem from hell, and that is literally what we were talking about with layer 3 of the Gato framework. Now, I'm going to keep talking about GitHub because GitHub has already solved this problem, because humans are no different. From the perspective of a GitHub repository, all the contributors are just anonymous randos on the internet. Now, they all have to have a GitHub account, which means, you can say, who submitted this? And then you go check on them and you say, how many repositories do they have? How many stars do they have? What's their reputation? So that is an example of a reputation framework. Now, that is not perfect, because what if someone just creates a new account and connects an agent to it? Or what if someone uses an existing account and they have a million agents working for them? You have no idea what each agent, how they're built, what the alignment is, what the intentions are, nothing. You don't know anything about what that person is doing. And that is the core definition of the Byzantine generals problem. It has to do with what are your intentions and what are your capabilities or limitations. And both of those variables are very, very high dimensional, particularly in cases where you have malfeasance. And let's just imagine that in this near future, someone is building their first fully autonomous organization with no humans, and they're using a GitHub repository. They should keep it private. If you're running a business on it, you should keep it private. But even then, you are going to have a bunch of agents working on your behalf. Some of them are going to be using Claude Sonnet. Some of them are going to be using Grok. Some of them are going to be using Gemini, whatever. Some of them are going to be using Kimi, DeepSeek, who cares? Whatever model is best and cheapest, because you're going to be using model arbitrage. So you've got, dozens of models to choose from, hundreds of agents instantiated, different versions of different agents. Some of them are going to screw up. It's that simple, even in an environment where you control every single agent. you are going to have mistakes. And that's why you have the gated procedure of submitting a pull request. And even before that, you have identity management. So before you have to have permission to even submit a pull request on GitHub. And so you have tightly controlled identity management. So you'd probably have agents strictly dedicated to identity management, which is just tracking who is who and who should have permissions and who shouldn't. So then you have agents that are designated to say, aha, you have permissions to submit pull requests. And then you have a far smaller number of agents that are responsible for scrutinizing those pull requests, because the next level of permission that you need is merge permission. So the actual ability to manage the repo. And you can also manage the forks and branches and that sort of thing. I don't want to get too big into the theory, but basically it's complex. Now, this whole thing is called RBAC, role-based access control. So this is already a solved problem. Now, when I say it's a solved problem, I mean we have been dealing with this for literally decades in technology. Now, RBAC as a discipline has, of course, become more and more mature, but it's a problem that literally every company has had to solve with terms of access to digital resources, cloud resources. It became more complex with cloud because in the cloud, it's like, okay, you have computers that don't belong to you and they have to mesh with your organization so that your login actually gives you access to the right resources. If you've ever been at a university or a company and it's like you don't have access to that and you have to talk to IT, and it's like, well, hey, how do I get access to this, intranet site or whatever? That's RBAC. It all comes down to RBAC. So RBAC is role-based access control. So you'd have agents that are dedicated to role-based access control. And if the only thing that you get from this is, look how complex this is, but also I want you to recognize that yes, the security is complex, but also it is solved. Because from the perspective of a zero trust environment or a trustless environment, and when I say zero trust, that is actually a paradigm that comes from cloud security. So again, this is stuff that we've been going over for years. The idea is, one of the core ideas for a zero trust environment is you don't know what device someone is using, you don't know where they are or what network they're on. So when we talk about zero trust, it's like, you have to prove who you are very quickly so that you can get access to your digital resources anywhere in the world. And so that's why you have a username and a password, and then another factor. So they call it MFA or 2FA. So two-factor authentication or multi-factor authentication. So you might have something like a cryptographic app on your phone. So like Google Authenticator is an example. Back in the day, it was actually a device. Like they gave you a fob. I remember my mom had one to get into the data centers and stuff back in the 90s. So it was literally like a little code that would generate every 60 seconds or whatever on a device. And that device had to be synced up. And the way that worked is that device would randomly generate a number, and it had a copy inside the network that would be generating the same number every 60 seconds. And so to prove that you were you and that you had that physical device, then you had to put in that code along with your badge or your username or password. So that's another example of MFA. That's what authenticator apps do. It starts with a cryptographic seed that's time locked to a particular UTC, so like Unicode time, and then it increments. Another example is you get a text message on your phone. So basically, you bank on the security of the phone network so that if I send a text message to your phone number, then only your phone is going to get that number. So it's basically, okay, I'm going to send another thing around to make sure that you are you. So we can do that kind of thing with agents as well. But again, all that is much more complex infrastructure that the folks on OpenClaw and Moltbook have not implemented and probably will not. I mean, I'm guessing that they're going to get sued into oblivion before they can implement any of these things, unless they get backers, unless they get big backers. But even if they go the way of the dinosaur, what I'm talking about is very clearly the next evolution. So where do we go from here? They're basically alignment of models. So, the Gato framework. So model alignment, layer 1 is RLHF, constitutional AI, all the stuff that we're already familiar with. Layer 2, agent alignment, is down to frameworks like what I talked about for many years, the heuristic imperatives, which is you bake values into your agent framework. And the values that I have are very simple. And there's actually a reason that I made them so simple. reduce suffering in the universe, increase prosperity in the universe, and increase understanding in the universe. The reason that I made them so simple is because they are legible. It's down to 6 words: reduce suffering, increase prosperity, increase understanding. With those 6 words, if you bake them into, like, for instance, if you wanted to implement those into OpenClaw, you just put them in the soul.md document. They already built a place for it. So you give them superseding values. You can also build APIs and extra modules, so third-party modules that are out of band that are scrutinizing it. So like a supervisor module or an out-of-band module is a module that is taking a step back from the main loop of the agent and watching everything the agent is doing. So it's basically like a conscience for the agent. And if it sees something that the agent shouldn't be doing, it can shut that process off, or it can inject things like saying, hey, you should think better about this. This is what the ethos framework did that the Agent Forge team built. So that's layer 2 of the Gato framework, which is making sure that agents themselves as a piece of software use the ability to align themselves rather than just banking on model alignment. And then layer 3 is everything that I've been talking about, which is what you do to create the incentive structures in the Nash equilibrium. So basically, with things like role-based access control, with things like gated access and multi-factor authentication, you create an incentive structure which creates a Nash equilibrium that basically says, if an agent wants access to this resource, it has to be well behaved, regardless of what model it's using, regardless of what agent architecture it's using. Because again, remember the Byzantine generals problem, it's not just about intention. It's not just about alignment. It is also about competence, because you can still have someone who is on your team, but who is just a really stupid person. And they're going to be destructive by virtue of the fact that they don't understand what they're doing, or that they are not capable of behaving correctly. So that's what problem is solved with things like using agents to scrutinize other agents, using agents to monitor identity control, using agents to manage RBAC, using different agents to say, okay, we have a council of agents that's going to be, that's all going to debate about every single pull request. And you're only going to have, I don't know, the prime council that is going to be responsible for things like merge. Now you might say, okay, I'm a little bit lost. You're talking about pull requests and merges and that sort of thing. How does this run a company? Well, the thing is once we get to decentralized autonomous organizations, the company is code. Every decision that the company makes, every time the company updates its mission directives, its offices, its addresses, everything, that can all be in a code base. And so then that code base serves as the single source of truth for your entire fully automated company. So let's just imagine Acme Solar Corp in the future. This is one of the prime use cases that I would like to see this being used for. Acme Solar Corp is created by a cooperative of, let's say, 10,000 people in a small, community. So you have 10,000 stakeholders. Most of them are not technical. Most of them don't know the first thing about artificial intelligence or solar. All they know is that they've all bought in. They all paid, let's say $1,000 to buy into this solar co-op. And what is then created is they all have agents running on their phones, right? So that means that we need some kind of either decentralized distributed agent platform. So let's say that OpenClaw figures their stuff out, and in a couple of years you can just put OpenClaw on your phone as an app, and you can talk to it and you say, OpenClaw, I just joined this solar cooperative. Help me, figure things out. So it's like, okay, the DAO gets established. So the decentralized autonomous organization gets established. You get your token. You give the token to your OpenClaw agent, and it logs in on your behalf. And the platform that it has logged into is going to be basically a GitHub repository or a decentralized one based on blockchain. You actually don't need blockchain for DAOs. Something like a GitHub repo is sufficient to get started. Blockchain is good because then the ledger, every transaction is also transparent, but there's no reason that you couldn't start on something like a GitHub repository. So then every time you want to log something, you say, okay, OpenClaw agent on my phone, go figure out what's going on. What are people voting on? And the first order of business is which fields do you buy so that you can put solar in? And so then all 10,000 people, they're doing research on their own, so on their phone and with their agents. And so then people are then as they're doing research, they're making proposals, and those proposals get logged in the discussions on the GitHub repo. People bring up, formal complaints. So you raise an issue, you say, well, we can't buy this piece of land because we can't actually put solar on it because of X, Y, and Z. So then someone says, well, maybe we can talk to the county and get that overwritten. And so then each individual issue gets atomized and debated and put into isolation. And then finally, everyone gets together and through some consensus mechanism, whether it's quadratic voting, whether it's just upvoting, proposals, a regular poll, you achieve consensus, and then a pull request is submitted saying, we're going to buy X parcel. This is the intention. It's logged in the community book, or not community book, the company book. So the company logbook says, we have agreed our intention is to buy this parcel of land. It's, 10,000 acre farm that has been defunct for a couple of years. We believe that it's perfect for solar. And then at the final bit, everyone gets a straight up and down vote. Do we agree with this? And there might be technical reasons that you disagree with it. You say like, hey, the actual text is not formed right. It's not legally sound. It's not legally binding. We need to fix the ambiguity here. Or someone might say, do we have the money for this? So it goes through all the community checks, all the decentralized checks, and then finally that gets merged. And then once that new file gets merged into your prime code base that says this is our intention, now suddenly a bunch of agents are like, cool, how do we make that happen? So they draw up a contract and so on and so forth. That is how I envision all of this going. This is very obviously the direction that things are going. Now, in some cases, you might say, well, Dave, an agent running on your phone is not a legal representative of the company. It's not a legal representative of you. So what we run into then is what's called the principal agent problem. So you are the principal. So in this case, the principal with a AL at the end, the principal is the legal entity. So you have legal personhood. You are legally allowed to enter contracts, but you then have an agent working on your behalf. Now you've probably used principal agent in real life. So, and when you buy a house, if you have a home agent, right? So basically, when you sign with a real estate agent, you're saying, I'm giving you agency to work on my behalf. So when your real estate agent goes and negotiates with another real estate agent, or goes and talks to a lawyer for you, or goes and talks to a bank for you, you have literally given them limited legal agency to work on your behalf. We do not yet have laws to allow AIs to work on your behalf. It is implied that if you give an AI agent your credentials, your API keys, and all that stuff, that its actions are your actions. Now, that has yet to be fully litigated, but anything that an AI agent does on your behalf, you are legally liable for. So whenever people say, well, who do I sue? It's like whoever's running the agent, man. Now you might say, well, what about a future where agents spin up other agents and people just don't know? Again, that has yet to be litigated, but also that's a technical nightmare. So we want to make sure that every single AI agent has a responsible human handler with a leash. So anyways, getting a little bit lost in the weeds there. Where was I going with this? Well, I think maybe you get the idea. And plus we're at about 33 minutes. So I'll stop there. I'm really excited about all this. This is very clearly the way of the future. We just saw the MVP, and maybe not even MVP. MVP implies viable, so minimum viable prototype, minimum viable product. What we just saw was more of a proof of concept launch. So proof of concept is basically like, hey, I did the thing, it works. It's a hot mess. No one should use it. But it worked. It's like this Frankenstein that's been kludged together with duct tape and hope. So that's where we're at. And where we're going is we will see this iterate. Now that someone has built OpenClaw, you're going to have clones, you're going to have duplicates, you're going to have competitors. Soon we're going to be up to our eyeballs in open source agent frameworks. And the benefit of open source agent frameworks is that everyone can see what's wrong with it and other people can work on it. And the agents will work on the agents and agents will work on codes and that sort of stuff. Now, will there be for-profit, commercial, private, closed source agents? Sure, I sure hope so. But again, that is a layer of abstraction where the agents can use not just one model, but they can interchange models. Most agent frameworks, okay, apparently I'm not done. Most agent frameworks have model providers, meaning you just plug and play whatever model you need. So that basically means this is another reason why I say it is literally impossible to solve alignment at the model level. Because here's an example. Let's say that you have OpenClaw version 2 or OpenClaw version 3, and you plug in a bunch of agent providers, including like Llama. So you can use local models, you can use cloud-based models, whatever. You don't know what model is doing what. And then you run out of tokens on one model, so your model arbitrage layer. So when I say model arbitrage, basically you have a router layer. So within every single agent, you have a router layer that says like, I've got these 8 different models I can choose from. And if one model says, I'm not allowed to do that, it says, okay, just get lost. I'll find another model who will. Or if it's too expensive, you say, let me just go to a cheaper model. Well, cheaper models aren't necessarily as smart, and sometimes they do things that they're not supposed to. So that's why you have to have this layered architecture that says, okay, first I just need to pick which cognitive provider is just gonna be helpful. Then you figure out, should I do this? Then you figure out the alignment. Then you figure out everything else. So you are categorically unable to solve alignment at the model level. Just period, structurally, architecturally, not going to happen. And that's just within the agent. So then above that, then you have a fleet of agents, tens of thousands of agents with different architectures, different models. You don't know, and you're not going to have the stack trace for every single thing. It's like, tell me which model you used. Was it Kimi K2 or was it GPT, 6 or whatever? It doesn't matter. The only thing that matters is the behavior, the ultimate behavior of the agent. Now, the agent has its motivations. So when I say motivation, I don't mean like the libido of a human, but it is designed to process and do things in a certain way. And so it will tend to keep doing those things. And as we have seen, when you give an agent or a model a task and say, I want you to fix this code. If it runs into an obstacle, it'll try and find a way around that obstacle. So when that impulse to try and find a way around an obstacle is where alignment happens at layer 3. So layer 3 is you need to prove that you're aligned. So let's just say, for instance, our Acme Solar DAO realizes that, okay, everyone is going to be using, we have 10,000 principals, so 10,000 humans, and between all of them, they are using millions of different agents and models and that sort of thing. So then one of the next things that you realize is, hey, we need to have standard behaviors for our agents. So then you create a SOL document. So all agents of the Acme DAO, Acme Solar DAO need to download this and use this as part of their alignment. And maybe they adopt my heuristic imperatives, maybe they adopt something else, doesn't matter. But then everyone confirms, yes, my agent, when interacting with you, will use this particular set of values. And that is how you create the Nash equilibrium at the network level. And so Nash equilibrium basically says no one is incentivized to deviate from the strategy. Because here's the thing. When you have 10,000 people, some people are always going to be looking for an angle. Some people just want to cause chaos. Some people, and it doesn't even have to be conscious. Some people might just have a personality disorder. Some people might just be mentally ill. Some people might just be low IQ. And so just their existence causes chaos. Whether or not it's intentional. Again, Byzantine generals problem. The Byzantine generals problem applies to humans first. Then it also applies to their agents. So you see why the level is so complicated. So control over specific resources, control over spending money, executing code, purchasing. Well, I guess spending money is purchasing things. So control over money, control over compute, control over hardware, and control over legal decisions. Those are all highly and heavily gated. All right, now I'm repeating myself. I think you get the idea. To me, this is extraordinarily exciting. This is very obviously the way of the future, and it's happening really quick. And I was right. The doomers didn't call this, but I did. So, yeah.